So the path of a soccer ball can be modeled by the relation h equals to negative 0.1 d squared plus 0.5 d plus 0.6, where h is the height of the ball, or the ball's height, and d is the horizontal distance from the kicker, both measured in meters. Find the zeros of the relationship. Okay, so find the zeros means what form does it have to be? Factored form. So if I want to do factored form, the first thing I have to do is do I have a common factor? In this case, you're going to have to try to factor out that number that's in front of the square term. Okay? This is what you want. This is your most, the first thing that you want to try. Because in order for you to be able to continue in factoring, you have to have that factored out. So if I can factor out a negative 0.1, if I divide each term by negative 0.1, so I get d squared minus 5d minus 6. You guys got that? All right, then because it's a trinomial, I have to do sum and product. So the sum, it's going to multiply to negative 6 and add to negative 5. Because both of them are negative, then my large number is going to be negative and my small number is going to be positive. So in this case, the two numbers are multiplied to negative 6. Then we have negative 2 and 3. Sorry, 2 and negative 3. Or we have 6 and negative 6 and 1. Because remember, the larger number has to be negative. 2 and negative 3, they add to negative 1, so that's not it. Negative 6 and 1, they add to negative 5, right? So this is going to be my factors. Which means I can factor this to x minus 6, x plus 1. Are we okay with this so far? Now, it's going to have to be d. Sorry. You're right. It's going to have to be d. Yeah? Ready question? Okay. Now, what would be my zeros? 6 and negative 1. If I set this equal to 0, d minus 6 equal to 0, bring the negative 6 over. So d equals 6, and d equals to negative 1. If I set d plus 1 equals to 0. Now, my question to you guys is this. What does the letter D and the letter H represent? H is the height of the ball, right? And D is the distance from the kicker, right? So if the kicker is standing right here and the ball is either in front of him on the ground or it could be on his leg, right? Can that ball be behind him before he kicks it? Right? Unless like they're playing a different match, but we're not talking about this, right? Right now, at this point, for this question, the ball is not on the ground. The ball would be on the ground as per this, 1 meter behind the kicker, which is not a scenario for us right now. Okay? So at this point, this number right here doesn't make any sense in our scenario. Okay? So if you're looking at that ball, if I'm going to graph this, let me just erase this. If I'm going to graph this, right, the ball is on the ground at negative 1 and 6. But technically, this part of the graph doesn't exist. Okay? Because that's in the negative distance, which is behind the kicker, which we're not talking about. Okay? So if you're going to think about this, the ball was on the kicker's leg, he kicked it, went up to the maximum height, then it went back down, touched the ground, and stopped. Right? It can't go below. It stops on the ground. Does it make sense to you guys? Okay? So in this case, that d minus 1 doesn't make any sense for us. Sometimes it does. You're going to see an example where you are going to have to use that negative distance. But in the case of this case, where the kicker is, it's not going to work. Okay? Are we okay with this? All right. What do the zeros mean in the context of this question? What do the zeros mean?
The distance from where the ball is.
Yeah, so the distance from the kicker, the distance of the ball from the kicker when what? When the ball is what?
Hit the ground.
Hit the ground. So, it's the distance of the ball from the kicker when the ball hit the ground. Okay, so how far from the kicker did the ball land on the ground?
6 meters.
6 meters. Perfect. Does it make sense? It has to make sense. You know, if it doesn't make sense, that means you're not understanding the question. You have to visualize it. Okay? Let's look the second question together. Let's do it. So if a small suspension bridge over a river can be modeled by the equation y equals negative 2x squared plus 4x plus 6, where x is the distance in meters from the edge of the river and y is the height above the ground also in meters. So we have a river, right? And then we have a bridge that's coming over the river, right? And basically we're looking at that scenario, okay? Now, that x is the distance in meter from the edge of the river. So if you're looking at the edge of the river, which is here, let's say, right? X is your horizontal distance from the edge of the river to the other ends of the bridge. And then y is the height of the river above the ground. What are your zeros? What do?
Factor.
I have to put it in factor form. First thing I ask myself when I'm factoring, common factor. Do I have a common factor here? What is it?
-2.
Negative 2. If I divide each one by negative 2, what do I have left? So it's going to be x squared minus 2x minus 3. In this case, that's a trinomial. So if it's a trinomial, that means I'm looking for two numbers. I'll multiply to negative 3 and add to negative 2. Negative 3. I don't know why I wrote negative 6. Negative 1 and... So look at your B and C. Both B and C are negative, so that means your large number is going to be negative and your small number is going to be positive. So it's going to be negative 3 and 1. That's the only thing that multiplies to negative 3, right? And does it add to negative 2? Yes, it does. Okay? So that means my factors are going to be x plus 1 and x minus 3. What are my zeros? 3 and
-1 and
look at this scenario. So what does it mean by -1 and 3? So it's going to be from the edge of the river, it's going to be -1 to one side, so it's going to be 1 meter to the left of that edge, and then it's going to be 3 meters to the right of it, right? So this is the edge of the river. It's going to be 1 meter, so that's why it's -1, and it's going to be 3 meters that way, and that's why it's +3, okay? So in this case, does it make sense that I use that -1 as a distance?
No.
So I have to omit this part of the bridge?
No.
Have only 3/4 of it? No, right? So in this case, so this is what I say, sometimes you have to kind of look at your question and see if it makes sense. This is where you have to use your knowledge, right? Your common sense, okay? Where I can't just have part of the bridge, right? Because I'm talking about, this is the river, right? To the left of it, it's gonna go 1 meter, and then to the right, it's gonna go 3 meters. Makes sense, right? Because I'm measuring a distance from a certain point. That's fine. Okay? Good. Now, what do they represent? So they represent the edges of the bridge. Now, how long is the bridge? Or how wide is it? 4 meters? Do we agree? Yes. Because it's going 1 meter to the left, 3 meters to the right. So altogether, it's going to be 4 meters. Okay? Good. A rider on a mountain bike jumped off a ledge. Her path is modeled by the relation h equals to -0.3 d squared plus 1.2 d plus 1.5, where h is her height above the ground and d is her horizontal distance from the ledge, both in meter. What is the height of the ledge? So what am I looking for?
Optimum.
When she jumped off of that ledge, was that her maximum height? Did she jump down like this? Or did she go up and then down?
Initial value.
So I'm looking for the
Y-intercept.
y-intercept, which is my initial value. Think about it this way. This is the ledge where she's jumping off from, right? And then she's jumping up and then going back down until she reaches the ground. Okay? So that ledge that she's jumping from, this is where she started. What do we call this point again?
Initial.
The initial value, or the y-intercept. Okay? Now, what form is this in?
Standard.
Standard form. What can I find from the standard form?
The Y-intercept.
Which is that what I'm looking for? So what can I say right away?
1.5.
The height of the ledge is 1.5 meter high. See? Sometimes you don't have to do too much work, but you have to kind of think about your situation. How far was the rider from the ledge when she landed? So what am I looking for?
The X and Y, the X-intercept.
The x-intercept or my 0, right? Because when she landed, that means when she touched the ground, right? So I'm looking for this specific point, which means I'm looking for the x-intercept, right? And what form do I have to be in? Factor. First, I have to factor out the negative 0.3. And I'm going to be left with d squared minus 4d minus 5. Because I have to divide each one by negative 0.3. And I'm looking for two numbers that multiply to what?
5.
Negative 5. And add to negative 4. Again, because both of them are negative, that means my large number is going to be negative and my small number is going to be positive. So 1 multiplies to 5, it's only 1 and 5. So that's going to be 1 and negative 5, and that adds to negative 4. So my factors are going to be, so it's going to be y equals negative 0.3, d minus 5, d plus 1. So what are my zeros? 5 and, yeah. So how far from the ledge when she landed? 5 meters, that's right. Because it can't be negative 1, that means it's before the ledge, right?